Our objective is comparing and ordering fractions and decimals, otherwise known as ordering and comparing rational numbers. Okay, it's easy to compare decimals, all right? The first thing you do, number one, compare the whole numbers, if there is one. 5 is always bigger than 4, right? Number two, add zeros so there are equal number of digits after the decimal point. And then compare. Just remember, negative numbers, when you're dealing with negative numbers, the order is reversed. So if the number looks bigger, it's farther from 0 when negative. So let's say you have 4.63 versus 5.62. Wow, I can compare 4 and 5, and I know that 5 is greater than 4, because 5 is bigger than 4, so I know this is true, okay? What about if I had 0.245 and 0.24? Well, I would add a 0 at the end, so I have 3 digits after the decimal point versus 3 digits after the decimal point. Now I just compare them. I ignore the decimal point. 245, 240. Well, 245 is bigger than 240, so 0.245 is greater than 0.24. What if I have 3.833 versus 3.83 repeating? Okay, here we need to add one 0 and then compare. So I'm going to add a 0 to this side, so it's 3.8330, and then I'm going to carry out my number of repeating decimals so I can compare. 3.8333. Okay, 4 digits after the decimal point, 4 digits after the decimal point. What's bigger? 8,330? 8,333. Hopefully you said 8,333. So that means this repeating decimal side is bigger because these 3 go on forever. But if you add a 0, because that ended, so you can add a 0 here, and then here you would add 3s, it's easier to see. Okay, so it's easier to see. All right, now I'm in negative land. I have negative 4.31 and negative 4.3. Well, add a 0. Okay, notice only the first one you could compare the whole numbers because that's how it normally is. It's just too easy if you're comparing whole numbers, okay? So now let's just compare 31 and 30. Well, because these are negatives, the order to 0 is reversed. Instead of getting bigger as you go away from 0, now you get smaller as you go towards 0. So 4.31 is farther away. Negative 31 is farther away than negative 30. Okay, negative 31 is farther away than negative 30. Now, let's say you have negative 17.252 versus negative 17.2556. Well, we add a 0 because there's 4 digits after the decimal here and 4 digits after the decimal here. Now I'm going to compare negative 2,520, negative 2,556. Which one is closer to 0? Well, hopefully you see that 20 is closer than 56 to 0. So this side's going to be greater. Okay. It's a little bit weird with negatives. Just figure out which is bigger and reverse it. That's what I do, honestly. Okay. But do remember about adding the zeros. It really helps. There are 3 ways you can use to compare fractions. Which you do depends on what the fractions are. Okay? First, convert to decimal. It's always easy to convert to decimal if you know the conversions because you've memorized the ones I gave you the other day. Or if you have a calculator. Of course it's easy if you have a calculator. Okay, so I know I have memorized 5/8 is the same as 0.625 and 2/3 is 0.6 repeating. Well, now I'm back to where I was on the other slide. I need to add some zeros or compare. Well, this time it's repeating, so I'm just going to add the 6's. 0.625, 0.666. Which is bigger? 0.666 is bigger because 666 is bigger. So that means this is bigger. It's all the same problem, okay? Because 0.666 is bigger than 0.625. Well, what if you didn't know the conversions? You can always get a common denominator and rewrite the fractions. So here I have the same problem, 5/8 versus 2/3. a common denominator. The lowest common denominator happens to be the common denominator when you multiply the two denominators, 24. 8 times 3 is 24, so I need to do 5 times 3, which is 15. And 3 times 8 is 24, so I need to do 2 times 8, which is 16. Now we just compare the numerators. 15, 16. Well, I know 16 is bigger, so that means this one was bigger too. Now let's do another problem with more numbers, okay? Negative 4 sevenths versus negative 5 sixths. Well, common denominator is going to be 42. Because 7 times 6 is 42. So now I say it was 7 times 6, so I do 4 times 6. So that'll be negative 24. I already wrote my negative sign on. And 7 times 6 is 42, so 7 times 5 is negative 35. Now if these were real numbers, if these were whole positive numbers, whole numbers, we would say 35 is bigger. But since it's in negative land, it's reversed. So this one is bigger. All right, that could be a lot of work, and you might multiply wrong. So here's another method. Okay, we just calculate what the numerators would be, not the denominators. Okay, it's less to multiply, so you make less errors. And you do this by doing cross multiplication. So here are the same problems again. Okay, 5/8 versus 2/3. Instead of converting completely, I'm just going to cross multiply the denominator of one diagonally to the numerator of the other, the denominator of one diagonally to the numerator of the other. So I'm going to say 8 times 2 is 16, and I write down the answer. I always go from the bottom to the top, from the denominator to the numerator, and you write down the answer next to the numerator. Okay, 3 times 5 is 15. Okay, look back up here. See the 15, 16? See the 15, 16? We just did the same problem, but we'd only found the numerators. Now, compare the numerators. What's bigger, 15 or 16? 16. So this side is bigger. Let's do another one. Same problem as before, negative 4 sevenths, negative 5 sixths. Okay, I'm going to cross multiply, multiply diagonally. 6 times negative 4. I'll write it over here. Well, I'll write it over here on this one. I should have written it over there on that one. Let me erase that for a minute. That's why I had done it twice. Okay, this was 15. This was 16. Now it's easy to show. All right, 6 times negative 4, negative 24. 7 times negative 5, negative 35. Which is closer to 0? Negative 24, so that side's bigger. It's the same numbers here, negative 24, negative 35, that we had here when we did the whole finding the new denominator, okay? But this, you're only doing half of the work, so hopefully you'll make half the mistakes, or even better, no mistakes. That's it.